Hey folks, let's talk about percent yield calculations today. Here's the thing, when you do a chemical reaction, you put in your reactants and you can predict using stoichiometry how much product you should make, but sometimes should isn't what happens. Either the reaction doesn't go to completion, you end up losing some as part of when you go to isolate your products because you spill some, or some just gets through the filter paper or whatever it is, or sometimes there's actually secondary side reactions that use up some of what your product should have been and take some of that and make something else out of it. So you don't always get the amount of product you would expect that you would ideally get out of a chemical reaction. And it's important to be able to tell someone, how much did I actually get? How well did my reaction go compared to the ideal situation that it would have been in? And that's what percent yield is all about. So percent yield actually has a very simple formula. Your percent yield is going to be your actual yield. So what you actually got. So your grams or moles, but typically we work in grams. And you'll take that amount and you'll divide it by the theoretical yield. Your theoretical yield is what stoichiometry predicts you should make. And you'll take that ratio and you'll multiply it by 100 to make it a percent. So your percent yield, that number, is going to be your actual yield over your theoretical yield times 100. Let's take a look at two examples so you can see how this plays out in practice. First up, if I have 34.6 grams of nitrogen gas and I react it with excess hydrogen to form ammonia, first off, what's the theoretical yield going to be for this reaction if all of that nitrogen gas were to form ammonia, and ammonia is NH3? And then what if I actually only made 39.4 grams of the ammonia? What was that percent yield? The first part of this problem is what you've already done. It's just a stoichiometry problem. So let's set this one up. As with all chemical stoichiometry problems, the first thing you have to do is balance your equation. So we'll drop in a couple of coefficients and get ready to set up a BCA table. We'll be good to go. Okay, here's my stoichiometry problem. I took my grams of N2, converted that to moles so I could put it in my BCA table. That was in blue. Converted my moles of N2 into moles of NH3. That's in green to predict how many moles of ammonia I would make. And then lastly, of course, I needed to convert this into grams. And so that's in pink. My final answer is 41.9 grams of ammonia would be what stoichiometry would predict for the amount of ammonia that would form in this reaction. I did this one in proportions. I'll do the next one in dimensional analysis just to keep everybody in the game. Okay, so that part you're already familiar with. That's just called your theoretical yield. So we're giving a new name to something you already know how to do. The last part's the new piece, and this is the percent yield. And so for this one, I want to calculate my percent yield. So I know my percent yield is going to be the actual yield. That's this 39.4 grams of ammonia that I actually made, divided by the theoretical yield, that number from the stoichiometry, which was 41.9, multiply by 100, and I get 94.0%. So I made 94% of what you would have expected. Let's take a look at another variation on this type of problem. So in this problem, I have 16 grams of lead 2 nitrate reacting with excess sodium chloride, and this reaction occurs with a 75% yield. So I already know what my percent yield is on the outset. The question this time is, what's the actual mass of lead 2 chloride that's going to form? Well, of course, we have to start with a balanced chemical equation. So we've got an equation written here for the double replacement reaction of the lead 2 nitrate with the sodium chloride to form the lead chloride and the sodium nitrate. We're going to do much as what we did before. We're going to start and we're going to do just a regular stoichiometry problem to predict that theoretical yield. Okay, so just a stoichiometry problem so far. Grams of lead nitrate to moles of lead nitrate. Moles of lead nitrate to moles of the lead chloride. That's in green. And then lastly, the moles of lead chloride to the moles of to grams of lead chloride for my theoretical yield. Okay, so right now we've got the theoretical yield. This is where we actually bring in the percent yield bit. In order to calculate my percent yield, remember, percent yield is the actual yield over your theoretical yield times 100. So I know my percent yield is 75. I know my actual yield, well, actually I don't know my actual yield. That's what I'm solving for. My theoretical yield that stoichiometry predicted was 13.44 grams. And then I would multiply that by 100. So let me just talk you through the math here. I'm going to start by dividing both sides of this equation by 100. And so that gets me 0.75, which is 75% as a fraction or as a decimal, is equal to x over 13.44 grams. And so then I just multiply both sides of this equation by 13.44 grams, and my actual yield, when I do that multiplication, is 10.08 grams. This is my actual yield. So this is my final answer to this question. So in effect, what we have is just an addition to a regular stoichiometry problem. You will use your regular stoichiometry problem to predict the theoretical yield. And then you can use the equation for percent yield to figure out how much you actually make, or if you know how much you actually made, to calculate your percent yield.